Special relativity, time dilation and train entering a tunnel. First problem. A train K' is moving at speed 0.9 c relative to frame K. The length of the train in frame K' is a equals 10 c meters. In frame K, the entrance of a tunnel is located at b equals 500 c meters from the origin of frame K. Note, the constant c here is unitless and is equal to 2.9979 times 10 to the power of 8. In the spacetime transformation, c is the speed of light and its unit is meter per second. At what time does the front of the train reach the beginning of the tunnel for both observer K and K'? The front of the train reaches the beginning of the tunnel at time ta relative to observer K and at time t' a relative to observer K'. When the beginning of the train reaches the beginning of the tunnel, the coordinate at the beginning of the tunnel relative to K will be xa equals b equals 500 c. And the space coordinate at the beginning of the train relative to K' will be x'a equals a equals 10 times c. At points A and A', the spacetime transformation are the followings. Substituting xa equals b and x'a equals a, we obtain the following equations. Computing Lorentz factor, gamma equals 2.2942. Solving for t'A, and substituting b equals 500 c and a equals 10 c, we obtain t'A is equal 231.05 seconds. Computing Ta, we obtain Ta equals 550.72 seconds. Briefly, when the front of the train reaches the beginning of the tunnel, we have the following standpoint. Observer K' sees that clock A' at the beginning of the tunnel registers the time t'A equals 231.05 seconds. Observer K sees that his own clock A at the beginning of the tunnel registers the time Ta equals 550.72 seconds. At what time does the end of the train reach the beginning of the tunnel? The end of the train reaches the beginning of the tunnel at time tb relative to observer K and at time t'b relative to observer K'. When the end of the train reaches the beginning of the tunnel, the space coordinate at the beginning of the tunnel relative to K will be xb equals xa equals b equals 500 c. And the space coordinate at the end of the train relative to K' will be x'b equals 0. Applying the spacetime transformation at point B and substituting x'b equals 0 and xb equals xa equals b equals 500 c. Solving for t'b, we obtain tb equals 242.16 seconds. Computing tb, we obtain tb equals 555.56 seconds. Briefly, when the end of the train reaches the beginning of the tunnel, observer K' sees that clock P' at the beginning of the tunnel registers the time t'B equals 242.16 seconds. Observer K sees that his own clock B at the beginning of the tunnel registers the time Tb equals 555.56 seconds. What is the time interval from the time the beginning of the train reaches the tunnel entrance and the end of the train reaches the tunnel entrance according to observer K and K'? The time interval from the time the beginning of the train reaches the tunnel entrance and the end of the train reaches the tunnel entrance according to observer K is delta t equals 4.84 seconds. The time interval from the time the beginning of the train reaches the tunnel entrance and the end of the train reaches the tunnel entrance according to observer K' is delta t' equals 11.11 seconds. It is clear that observer K is registering the ticks of two different clocks in frame K' using one clock located at the beginning of the tunnel. Therefore, the period of time measured by observer K should be shorter than the period of time measured by observer K', and that is what we have obtained. We can use the following relation to compute the time measured by one clock in frame K. Delta t equals 1 over gamma times delta t prime, and that is equals 4.84 seconds. Second problem. A traveler K' is moving at speed 0.9 c relative to frame K. He starts his journey at space-time coordinates ta equals t prime a equals 0, xa equals x prime a equals 0, and travels for a duration of 50 seconds. What is the duration of his travel according to K? What is the distance traveled by observer K' relative to observer K? What is the time reading at the end of the journey according to K and K'? Observer K' travels with single clock, and his travel duration time is registered in frame K using two different clocks. Therefore, the duration of his travel according to observer K will be TB minus TA equals 114.71 seconds. The distance traveled by observer K' relative to observer K will be xb minus xa equals 3.095 times 10 to the power of 10. The time reading at the end of the journey according to K' will be TB equals 50 seconds. The time reading at the end of the journey according to K will be TB equals 114.71 seconds. Briefly, the distance traveled by observer K' relative to observer K is equals 3.095 times 10 to the power of 10 meters. The duration of his travel according to K is equals 114.71 seconds.